Assalamualaikum everyone. I am Mahmoud Hassanimon, ID 1910109 from CSE425 Section 3. Today I am going to present the topic overfitting. Today I am going to present what is overfitting, how to detect overfitting, how to reduce overfitting, and last but not least is conclusion. So first of all, what is overfitting? Overfitting occurs when our model becomes really good at being able to classify or predict on data that was included in the training set but is not so good at classifying data that it wasn't trained on. So essentially, the model has overfit the data in the training set. So how do you know if our model is overfitting? We can say the model overfitting based on metrics that are given for our training and validation data during training process. When we specify a validation set during training, we get metrics for the validation accuracy and loss as well as the training accuracy and loss. If the validation metrics are considerably worse than the training metrics, then that's indication that our model is overfitting. We can also get an idea that our model is overfitting if during training the model metrics were good, but when we use the model to predict on test data, it's not accurately classifying the data in the test set. The concept of overfitting boils down to the fact that the model is unable to generalize when meaning it's learned the features of the training set extremely well, but if we give the model only data that slightly deviates from the exact data used during training, is unable to generalize and accurately predict the output. So overfitting is incredibly common issue. Our next part is how to reduce overfitting. We can reduce overfitting by these 4 steps: to add more data using data augmentation, then to reduce the complexity of the model, and then drop out. We'll cover this topic in our next slide. First of all, the point is to add more data. The easiest thing we can do as long as we have access to our model is to add more data. The more data we have to train our model on, the more it will be able to learn from the training set. Also, with more data, we are hoping to be adding more diversity to the training set as well. For example, if we train a model to classify whether an image is an image of a dog or cat, the model has to see image of larger dog like labs, golden retriever, and the boxers. That is practice. But if it sees a Promethean, it might not do so well because Promethean is a small kind of dog. So if we add more data to the training set to encompass more breeds, then our training data will be more diverse and the model will be less likely to overfit. Another technique to deploy reduce our overfitting is to use data augmentation. This is the process of creating additional augmented data by reasonably modifying the data in our training set. For image data, for example, we can do this modification by cropping, rotating, flipping, or zooming. The general idea of data augmentation allows us to add more data to our training set that is similar to the data we already have, but it is just reasonably modified to some degree so that it's not the exact same. For example, if most of our dog images were dogs facing to the left, then it would be reasonably modification to add augmented flipped images so that our training set would also have dog faces to the right. Now, something else that we can do to reduce overfitting is to reduce the complexity of our model. We could reduce a complexity by making simple changes like removing some layers from the model or reducing the number of neurons in the layer. This may help our model to generalize better to data it hasn't seen before. Now, the last step I will mention for reducing overfitting is something called dropout. The general idea behind dropout is that if we add it to a model, it will randomly ignore some subsets of given layer during training. It drops out the nodes from the layer, hence the name is dropout. This will prevent these dropped out nodes from the participating in producing a prediction on the data. This technique may also help our model to generalize better to its better it hasn't seen before the data. Now I will going to cover the pros and cons of overfitting. First of all, in pros, if anyone is confident that overfitting on their dataset will not cause problems for situations not described by the dataset, then overfitting may be good. But on the other hand, in cons, in regression, overfitting produce misleading R-squared values, regression coefficients, and p-values. Now, in the uses of overfitting is a modeling error that occurs when a function is too closely aligned to a limited set of data points. As a result, the model is useful in reference only to its initial dataset and not to any other datasets. In conclusion, overfitting is a tremendous enemy for a data scientist trying to train a supervised model. It will affect performances in a dramatic way, and the results can be very dangerous in a production environment. And those are my references. And if you have any question, feel free to ask me. Thank you, everyone.